Coders, developers, engineers in training, students, YouTube bots, welcome to Real World Programming for Beginners. This is the second video in a series on developing a simple calculator for Android devices. In this video, the focus will be on some key design considerations that must be addressed for successful implementation of your calculator project. Now, if by chance you are an iOS or cross-platform developer, do not run away, because everything we are going to talk about in this video is platform, language, and framework agnostic. Regardless of the system or platform that you are using, there are some common challenges that you'll have to find solutions to if you want to program a calculator. I will begin this session by identifying three major challenges. Challenge number one. Define a set of valid characters and symbols that your calculator would use. So this isn't that big of a deal because by nature, a calculator requires an interface, whether it's a digital interface or a real-life calculator that uses actual buttons, and the input into the calculator, again, whether it's real or virtual, is limited by those buttons. But it's still important that that set of valid characters and symbols be explicitly identified, because this will determine the functions that are available for the calculator that you are designing. So for this simple calculator, the valid set of characters are the numbers 0 to 9, the plus sign, the minus sign, the division sign as a /, and the multiplication sign as an asterisk. If you are really good at programming, you can replace any of these symbols, and I'm speaking here about the mathematical operators, with something a little more aesthetically pleasing. For our first calculator, we'll stick with this. We'll make changes along the way. Okay, so that covers our design challenge number one. Design challenge number two. Data entry by a user is constrained by the calculator's interface, user interface or real-world interface. Now, this doesn't stop a user from entering some expression that isn't either computable or arithmetically sound. So this presents a challenge for our calculator designers. What do we do with expressions such as this one? How do we deal with them? So as a designer, there must be some method of dealing with expressions such as these. So they may be constructed from valid characters, but they may not be expressions that can be evaluated successfully. Of course, we are speaking mathematically here. And that carries us to design challenge number three. In the event that we actually have an expression that is constructed of valid characters, it is actually computable and it can be evaluated to yield a result, we still have the issue of how is the expression evaluated. So what I mean here is that it isn't sufficient that an expression can be evaluated to yield some mathematically correct answer. For example, we have here 10 plus 10 minus 10 plus 10. And the answer could be 20. And I suspect the overwhelming majority of you all would agree on 20. Or it could be 0. So the point I'm getting to here is that to believe that it's 20, it must be predicated upon something. why is this expression evaluated as 20 or 0? And the answer to that is there are methods of defining how an expression is evaluated. So in this calculator as well, I would have had to look at some way of evaluating mathematical expressions. It's explained in the document available in the download package. And that's the most important thing, that you are aware of how you are going to do your evaluation, and that the method that you choose must be explicitly defined. So that covers a brief description on these 3 design challenges, and we look at how they were approached in this simple calculator app. Okay, so let's go into our program code and figure out how do we define a set of valid characters for the simple calculator. So I'm in the Java section of the Android Studio project for this calculator, and the logic is composed of 3 files actually, and the simple calculator is an activity, an Android activity. We want to know how we defined the set of valid characters or symbols that could be used in our simple calculator. And we saw in this slide that the valid set are the numbers 0 to 9, plus sign, minus sign, forward slash, and the asterisk. And in program code, it's pretty simple to do this. So I declare an array list, and this is not the best data structure to use, but the course is tailored towards beginners, so we don't want to get into stacks, queues, or heaps, trees. This is an array list here, and an array is a data structure that is used to store type multiple data values. So it's something like a container. It isn't like a variable that could store only a single value. So in this array list, I have stored a list of characters here, and this array list is called operators. So the operators list stores a list of valid operators. So this class does that. It defines a list of valid operators, and a method that this method checks an array. And let me be a good host and actually document this. So I apologize that this wasn't documented before. Okay, so I have added the missing documentation. My apologies again. This method here, and a method is a short block of code that it does something. So what this method does is that it allows us to test a character. So that, for example, a character entered at the calculator screen, and it allows us to check inside this operators array to determine if the character is a valid operator. That's simple. The operands are stored in a very similar instance. So again, an array list, and whether you know what an array list is or not, it's a container that stores a list of valid operands. So here our valid operands are the numbers 0 to 9, and we have here the decimal point, but it is not implemented in this version of the simple calculator. Similar to the operators, we have an array list with valid characters, and we have a function here again, undocumented, which is bad, that checks within our array to see whether some character entered at the calculator screen is a valid operand. So if you think about this intuitively now, every time a digit is pressed on your calculator screen, somewhere this function is run and this function is run. So it will actually test each character against both of these functions to check whether it's an operand 0 to 9 or it's an operator plus, minus, subtract, or divide. So that explains how challenge 1 was dealt with in code. Let's move on to challenge 2. So let's go into our code to find out how the simple calculator code dealt with expressions that were constructed from valid characters. But just like our expression here, it may not have been a sensible expression. It may be a sensible expression, but not mathematically, not computable. So let's go into the code and see how this was dealt with. An in-depth explanation of how we deal with expressions that may not be computable or may not be able to be evaluated mathematically would be an entire video of its own, but I'll still give you an idea of how it was dealt with here. So this piece of code here is where the app would get what the user enters, and when the user clicks enter, the enter button, that is when the app would attempt to evaluate an expression. So it calls this logic class here, and it calls a method of the logic class. This current expression is whatever the user would have entered at the calculator screen. So let's go to our logic class and see what happens here. And the logic class, we saw the method was run calculation block. So this is the run calculation block method. So again, in another class, I'll go into it, another session, I'll go into it in more detail, but this is how it deals with the expression. So the first thing it does, it checks to see if the expression is valid. If it is valid, it will check to see if it is an arithmetic expression, meaning that it is possible to evaluate it mathematically. And if these two things are satisfied, then it would go on to perform some other functions. So we are not going to discuss the other functions right now. Our challenge 2 is how do we deal with these with a valid expression, but we are not sure it's mathematically sound. So let's go to this method here, is arithmetic expression, and this chsec, that's short for character sequence here. So it's going to take our character sequence, and we are looking for the function is arithmetic expression. Great, so this is it, and I did document it properly. And it takes an expression. It starts at the first character, and notice it says here operator is arithmetic operator. So if we go in the operator class, remember we were speaking about this earlier, it will take each character and check to see if it's a operator or opera. Okay, and this is the last major design challenge. How do you do your evaluation? So again, it's not solely important to have an expression that gives an answer. You must state how your expression is evaluated to arrive at whatever answer you get. And this is a very important point, and if you were to read your manual, for example, for a scientific calculator that you may own, a real calculator, you would find somewhere in your manual an explanation of how that calculator evaluates expressions. And that is something that is really important in the scientific community. The casual user wouldn't really think much about that, but there are instances where persons need to know how a calculation is being done within a calculating device. For this app, the expressions were simply evaluated from left to right, and that is stated explicitly in the design document, Design for Consideration. And because I have stated that, there's no expectation that it is evaluated in any other way. So for example here, the answer could be 20 or 0. I'm sure 99% of you would go with 20. And the reason for that is that we have already been conditioned to calculate this expression in a certain way from left to right. And that doesn't invalidate some other method of calculating. For example, if we had parentheses around each pair of tens from left to right, the answer would actually evaluate to 0, meaning that the parentheses changed the method of evaluation. So the method of evaluation must be clear, must be well articulated and defined, so that a user of your calculator would not have unexpected results for certain types of calculations. Okay, so let's talk a bit about this simple calculator activity. And an activity is an Android class that provides the graphical user interface for an Android app. So that's why simple calculator extends app compat activity. So you wouldn't have seen that with either of the other classes, logic, operand, or operator. So these were logic type classes that handle the functionality and behavior of the simple calculator. And the simple calculator Android activity, this is the code that ties everything together. So this ties the app logic together, it ties the user interface together, and this is the actual code here that allows it to connect to the Android layout. So we see it here, r.layout, and this here is the actual android.xml file, a reference to that file. So, and that file, we already made the connection between the user interface design, which is this, and the data, which is this here, the update. From lesson 1, when we were working with event handling, when we connected this event handler button clicks to all of the numbers as well as the mathematical operators. So whenever we click a button, this piece of code here is executed. And here, enter pressed, this basically activates the calculation block, which we see down here. And this is where the app actually begins running. Not running, sorry, but calculating. If you have any questions, post them in the comments below. And the code is here. You all can download it. You all can go through it. If you have any specific questions, just put them in the comments below. And we'll do a video and give an explanation as to how other certain functions were achieved, how certain problems were solved. So that's it. Thank you for tuning in, and I look forward to seeing you on future videos. God bless you wherever you go, and hoping to see you soon. Take care. Bye.